All right, let's dive right in. Today, we're going to pull back the curtain on programming. We're going to get right into the core ideas, the fundamental stuff that makes literally all of our digital tools work, from your phone to your laptop. So let's get into it. Seriously, have you ever thought about that? You click a button, you send a message, you tap on an app, and in that split second, something just happens. Well, that something is programming. It's the magic behind the machine. And today, we're going to figure out exactly how that magic is made. And really, at its heart, it's that simple. Programming is just giving a computer a very, very specific to-do list. We write out a set of step-by-step instructions, and the computer follows them perfectly every single time. It's the ultimate instruction manual. So here's our game plan. We'll start with the big picture, looking at a couple of major programming styles. Then we'll get into how you actually plan a program, which is super important. After that, we'll break down the absolute essential building blocks of code and wrap it all up. Okay, first up, let's talk about the different ways you can approach writing those instructions. See, it's not a one-size-fits-all kind of deal. There are different philosophies or styles for how you organize your thoughts and your code. Let's look at two of the biggest ones. On one hand, you've got event-driven programming. This is basically a wait-and-see approach. The program just kind of sits there, waiting for you, the user, to do something. You click a mouse, you press a key, that's an event, and that event triggers a specific chunk of code to run. Think about it. That's how almost every app and website you use works. Then you've got object-oriented programming, or OOP. This style is all about organizing your program into these neat little bundles called objects. It's like creating digital blueprints for real-world things, which makes building really complex software way more manageable. Let's make this real with the car object example. An object bundles two key things together. First, it's got data. That's the information about it, like its color, its speed, its model. Think of these as its characteristics. Second, it's got functions. These are the actions it can perform, like starting up, stopping, or hitting the brakes. By packaging the data and the actions together into one tidy object, code becomes way more organized and reusable. Your user profile on a social media app, that's an object. It has data, like your name, and it has functions like add a friend. So you've got a style in mind, but wait, you don't just jump in and start typing. No way. The best programmers are planners. They think, they strategize, and they create a blueprint before writing a single line of code. Honestly, this planning part might just be the most important step of all. And the plan really boils down to two simple steps. First, you have to truly, deeply understand the problem you're trying to solve. What exactly are you trying to do? And second, you map out a step-by-step solution. In the programming world, we call this detailed recipe an algorithm. It's the logic, the core thinking that's going to solve your problem. And check this out. This is how you actually do that first step. For this simple problem, you just ask yourself, what information do I need to start? Those are your inputs. In this case, the marks for 5 subjects. Then you ask, what do I need to get at the end? Those are your outputs, the total marks and the average. See? Once you know your start and your finish line, you can figure out the path. That path is your algorithm. Here, the steps would just be 1, add the 5 marks together to get the total. 2, divide that total by 5 to get the average. Boom, that's the logic, all before you write any code. All right, so we know the high-level philosophies and the planning process. Now let's zoom all the way into the atoms of programming, the absolute basic ingredients that every single program is made of, no matter how big or small. First up, commands, which are also called keywords. These are the action verbs of any programming language. They're special words reserved by the language that have a very specific fixed meaning. When the computer sees a word like if or begin, it knows exactly what it's supposed to do. This is a perfect way to think about it. You can't just wake up one day and decide a stop sign means speed up. That's not how it works. Its meaning is universal and non-negotiable. It's the exact same with programming commands. They are the fixed rules of the road that the computer depends on to understand us. So if commands are the verbs, then what are the nouns? Well, that's data. Data is just the raw stuff our programs work with. It's the numbers, the text, the symbols, all the information we need to store, change, and show to the user. Someone's age, the price of a coffee, a username, it's all just data. But here's the crucial part. The computer has to know what kind of data it's looking at. Is it a whole number? Is it a number with a decimal, a letter, a word? This is where data types come in. They are basically labels we stick on our data to tell the computer exactly how to handle it.
And this slide breaks it down perfectly. An integer is just a whole number, no fractions. A float is for any number with a decimal point. A character is for one single letter or symbol. And a string, think of it like a string of letters, is for a sequence of characters like a word or a whole sentence. Using the right data type is so important for making sure your program works correctly and efficiently.
I love this analogy because it just clicks, right? You wouldn't try to carry water in a cardboard box, you'd use a bottle. Data types are the same idea. They're the right containers for the right kind of information, making sure nothing gets messed up. Phew, okay, we have covered a lot of ground, from big picture thinking all the way down to the tiny little details. So let's do a quick recap and load up your new programming toolkit. So let's bring it all home. Programming is just writing instructions. You can use an event-driven style that reacts to what a user does, or an object-oriented style that models the world with objects. Your instructions are built with fixed commands that work on raw data, and that data is always organized by its data type. That is the foundation of everything. I want to leave you with this thought, because it's so true. It's easy to think programming is all about memorizing thousands of commands. It's not. At its core, it's about solving puzzles. It's about being a detective and a builder all at once. It's really a skill of figuring things out. So I'll leave you with this question. You now have the blueprint. You understand the basic materials and the different approaches to building. So forget about the specific code for a minute. What's the first problem you would want to solve?